तो बहुत ही बेसिक, सबसे पहले लाइक स्टार्ट आई थिंक इन thermodynamics. You have to study about thermodynamics. Thermo means heat and dynamics it means motion, है ना? Motion. Thermo का मतलब heat तो नहीं, thermal energy से है, which can be transferred via heat. That's one form of uh, transferring energy. That is in the form of heat. वो आगे हम लोग पढ़ेंगे. तो thermo और dynamics दो वर्ड से बना है. Thermo means thermal energy and dynamics means movement. So thermo dynamics में thermo plus dynamics. So you are learning about the kinematics आप पढ़ते हैं. In that you only learn about the motion, है ना. उसके बाद you learn about dynamics. पढ़ते हैं ना, kinematics के बाद dynamics है. The Newton laws of motion वाला जो portion, whatever you are learning in Newton's laws of motion, that is known as dynamics, in which you also learn about the cause of movement. Okay. So in thermodynamics, we are going to learn about thermal energy is movement of thermal energy, which you can in a very namely, you can call it heat, but heat is not a form of energy. Heat is a mode of transfer of energy. You are going to learn it later on. अभी तक तो आपको लगता होगा heat energy कुछ होता है. There is nothing as such heat energy. There is thermal energy, and thermal energy can be transferred from one system to another in the form of heat. Dynamics means movement. Now, in thermodynamics, you are going to learn about the branch of science which studies the motion of thermal energy. That is known as thermodynamics. If we get the study of motion of thermal energy is called thermodynamics. It ends in 1.5 hours. So if you're starting at 6:30, it will be ending at 8. When is Maghrib, by the way, Shaima? आपकी तरफ मगरिब कब है? गॉट इट शाइमा, ये सर कुछ तो बोल दीजिए भाई, आप लोग सवाल पूछ कैसे शांत हो जाते हैं? अच्छा ठीक है, तब देन फाइन ना. The study of motion of thermal energy is called thermodynamics. Thermodynamics basically, na, if you want to study thermodynamics, then there are two different thermodynamics. तो एक तो है क्लासिकल थर्मोडायनेमिक्स, and there is one that is not quantum, but we call it statistical thermodynamics. You don't have to study the statistical thermodynamics, you only have to study classical thermodynamics, which is going to involve large macroscopic molecules, macroscopic objects, I would say. एक thermodynamics होता है, that is classical, and the other one is statistical. If you opt for physics or chemistry, in both the subjects, you need to learn statistical thermodynamics in higher classes. So whatever we are going to study in 11th standard is going to be classical thermodynamics, which deals with macroscopic objects. Macro, macro, है ना? Macroscopic objects, बड़ी बड़ी चीजों. Statistical thermodynamics is going to deal with microscopic objects. ठीक है? So we are only going to learn about this. We are not going to learn about statistical thermodynamics. You are नहीं पढ़ना. Raise your hand if you are done. Then we are going to start with some basic terminologies that we are going to use in this particular chapter, and we are going to move towards the most basic terminology के बाद फिर हम लोग आगे बढ़ेंगे. Waiting for Abir and Alina. Waiting for Abir and just waiting for Alina. Just waiting for Alina. अलीना आप क्लास में है? अलीना आर यू देयर इन द क्लास?
Yes, sir.
ठीक है ठीक है. Others you can lower your hand. Alina, just let me know once you're done.
Sir, my screen is not working properly.
Your screen is not working. So what should I do then?
No, sir,
Oh,
that means I completed.
अच्छा. आप लेकिन कहाँ क्या था?
सर मेरी स्क्रीन ठीक से काम नहीं कर रही, वो मैं ऑन नहीं कर पा रही वो हैंड.
अच्छा अच्छा ठीक. ये बोलिए ना कि सर आई हैव. ठीक है फाइन. सो राइट द हेडिंग बेसिक टर्मिनोलॉजी. इन बेसिक टर्मिनोलॉजी नंबर 1 इज सिस्टम. ठीक है. सिस्टम. What is system? System is that part of universe that is under observation, जिसको हम study करने वाले हैं. In which we are going to do thermodynamic study. In which we are going to look at the motion of thermal energy. Please write a specific part of universe. Part of universe which is under observation. Which is under observation. ठीक है. Now we can divide system into two different categories. We are going to divide a system into many different categories. लेकिन स्टार्टिंग में बहुत हल्के से हम लोग ये कर सकते हैं. System can be divided into two categories: heterogeneous and homogeneous. Heterogeneous and homogeneous system. Now, heterogeneous system. In heterogeneous system, the components of the system will be in more than one phase. That means more than one state, like solid or liquid, liquid and solid, liquid, gas. All of these are there in heterogeneous system. Components of system. Components of system have more than one phase, yes, state. Homogeneous, I hope you can write it on your own. Components of system. Components of system have only one phase or state. ठीक है. एग्जाम्पल्स कर ले कुछ. Let's do some examples. You have to tell me whether it is सवाल टाइप से लिख दीजिए. Classify the following as heterogeneous, and homogeneous. ठीक. One is boiling water. Two is block of iron. Third is pencil. Fourth is human body. I hope you have written the previous जो classification हमने दिया था यहाँ पे. Glass of water. Classify the following as heterogeneous or homogeneous. हो जाएगा ना? अबीर, अलीना, जसनीन, शायमा एंड जैनब. हम्म. हो जाएगा ना? अरे बोलो यार, हाँ या ना तो बोलो.
यस सर, हो जाएगा.
What about others? अलीना, जसनीन, शायमा, जैनब.
Yes, sir.
Send your answer in Zoom chat. You can just क्या कर सकते हैं हम उसमें? You can just separate the answer by comma, है ना? Separate the answers by comma. But don't take too much time. Take 2 more minutes. Okay, Shaima. हम लोग देखेंगे, है ना? Just wait, Shaima. I'm waiting for others. Please send the answer quickly. मतलब सबका आंसर आना चाहिए, हम बता रहे सही से. ठीक है? अबीर, अलीना, जसमीन, शाइमा. शाइमा का तो आ गया. जैनब. All of you have to send the answer. In the answer you can write don't know. I don't know, sir, but you have to send the answer. Okay, I've got answer from Jasleen. Waiting for Abir, Alina, and Zainab. Please send it quickly. Send it to Salim. I've got answer from Abir. I'm waiting for Alina and Zainab. Jasleen ने भेज दिया. हाँ, Shaima, Jasleen, Abir is done. Shaima, Jasleen, and Abir. Waiting for Alina and Zainab. Okay, Zainab has sent it. Alina, just waiting for you. Time is up. Alina, जल्दी भेजिए.
सर भेज रही हूँ.
हाँ तो जल्दी भेजिए भाई, कितना टाइम लग रहा है? चलिए सबका आंसर आ गया. Now I'm writing, है ना? Boiling water is going to be heterogeneous, right? Why heterogeneous? Because boiling water will have water as well as the water vapors, right? So boiling water will be heterogeneous. Block of iron is going to be homogeneous. There is nothing instead of block of tensile is also going to be homogeneous, right? Because tensile is only going to have solids. Human body is obviously heterogeneous because it is, for example, your lungs is holding air, your blood is liquid, right? Your bones are solid and so on. Glass of water is also going to be heterogeneous because glass will be of certain other, glass will be obviously solid, water will be liquid. So glass of water is going to be what? Heterogeneous. But if I say water inside the glass, so I am observing the water, right? So then it is going to be homogeneous. But when I say glass of water, it will be heterogeneous. Although these questions are not going to be asked, but I'm just making some introduction and I'm just setting the scene, setting the background for all of you guys. ठीक है, चलिए नेक्स्ट लिखिएगा सराउंडिंग. First is system. All of you understood this 5 example? Yes or no? Please tell me.
Yes,
Yes,
sir.
sir.
Please write the remaining part. The remaining part of universe, which is not part of the system, which is not part of the system. For example, मान लेते हैं ये आपके पास this is the complete universe, है ना? Let's suppose this is complete universe. So and let us suppose this is the system, है ना? So this whole part is will be, और ये पूरी चीज जो है ना, everything, this is universe. ठीक है, this part is, नहीं देखा होगा ना, this part is system, and the rest of the part, for example, this part is universe. Oh, sorry, this part is surrounding. This part is surrounding. ठीक है, यूनिवर्स ये अंदर वाला सिस्टम, और जो ये रेड पार्ट है ना, दिस रेड वन, दिस इज नोन एज बाउंड्री. बाउंड्री की भी डेफिनेशन आएगी. So the remaining part of universe which is not the part of system, उसको क्या कहते हैं? Surrounding कहते हैं. But that is a definition of surrounding. Practically we don't use that particular definition, है ना? हम लोग generally surrounding को क्या बोलते हैं? The part of universe which can influence the system or get influenced by the system. ठीक है? So for example, if I talk about let's think about fireworks, for example. So if you have pataka, na, then if you are so close to the if you are so close to the firecracker, if you are so close to the firecracker that it may burn you, right? So that is one type of closeness that you have with the firecrackers. You can feel the heat and everything. Now, if you are a bit far away, you can hear it and see it. If you are even further away, then you may not even hear or see the firecracker. Fine. So when we talk about surrounding, practical sense, then we talk about that part of universe which can influence the system or can get influenced by the system, can get affected by the system. Does this make sense? Yes or no? Please tell me. Abir, Alina, Jasmine, Shaiman, Zainab.
Yes, sir.
Right. So, like for example, if I talk about bombs, like the chota mota jo bomb hota hai, in that case, what is the surrounding? The surrounding is wherever you can hear it actually. But if I will talk about atom bombs, then the surrounding will become the complete city or the complete state, or a very large area, है ना? That will get affected by the changes in that particular system. ठीक है? But these are philosophical things, है ना? ये आपको मतलब ऐसे कोई पूछेगा नहीं, इतना deeply कोई नहीं पूछने वाला, बस एक चीजें बता देते हैं. Now, third thing that we have just now seen is boundary. ठीक है, boundary. Third is boundary. ठीक है. System and surrounding. System and surrounding are separated by boundary. ठीक है, boundary can be. अच्छा. We classify boundaries into many different categories and on the basis of many different things. So boundary, इसके बाद लिखिएगा types of boundary. Types of boundary. Types of boundary में, first of all is on the basis of existence. On the basis of existence. दूसरा we classify it on the basis of nature. On the basis of nature. Last we classify it on the basis of, on the basis of thermal conductivity. On the basis of existence, done, Sunika. On the basis of existence, it can be real or imaginary. And for example, if I have a very closed container and in which reaction is happening, then we have a real boundary, and the container is the boundary between system and surrounding. For example, our Earth, if anything is happening in our Earth, or if we are having a boiling water, then it is open. Or we can say there is imaginary boundary. There is no boundary aspect, khula hua ek area. Now, on the basis of nature, we have two, rigid or flexible. Rigid, or it could be flexible. So for example, अगर rigid हुआ, then it will not change. ये ऊपर नीचे नहीं हो सकता है. But if it is flexible, then it can. अगर आप इसको, you can compress it and you can expand the boundary. है ना? I hope you can see that. Yes or no? Make sense? Abir, Alina, tell me guys, all of you. Make sense? Yes or no? Please tell me. ठीक है?
Yes, sir.
Now, on the basis of thermal conductivity, you can classify it into two different categories. एक को बोलते हैं adiabatic. क्या बोलते हैं? Adiabatic और एक को बोलते हैं diathermic. One is known as adiabatic or the other one is known as diathermic. So what is diathermic? Which conducts diathermic. What will happen? This will conduct कंडक्ट हीट या फिर ऐसे कंडक्ट ऐसे नहीं सही रहेगा, अलाउज पासेज या फ्लो ऑफ हीट ना, इसमें हीट कैन बी पास्ड इन दिस सिस्टम. The other one is adiabatic. And this doesn't allow passage of heat. Raise your hand if you're done writing. Just waiting for Alina. Next up, there's one more heading that is important. That is types of system. एक तो heterogeneous homogeneous उतना ज़्यादा important नहीं, this is important. Types of system. Number one, feel right, open system. Open system की basic definition क्या है? A system in which the transfer of matter as well as energy is possible. ठीक, open system क्या होगा? Transfer of both matter and energy. Transfer of both matter and energy is possible. ठीक है, so you have this is the system. दोनों चीज इनटेक एज वेल एज इनपुट आउटपुट दोनों हो सकता है. किसका? इसका मैटर का भी और एनर्जी का, दोनों. फॉर एग्जाम्पल ह्यूमन बॉडी है ना, फॉर एग्जाम्पल ह्यूमन बॉडी, प्लांट, what else, and we can have open bucket या open beaker. और समझ में आ रही है? Similarly earth, all of these are open system. Second one please write.
सर ओपन बकेट कैसे?
ओपन बकेट वो अगर आप धूप में रख दीजिए तो गर्म हो जाएगा, उसमें पानी डाल दीजिए तो पानी जल जाएगा ना,
ओके सर, यस सर.
है ना. सेकंड, क्लोज्ड सिस्टम. In closed system, what will happen? The transfer of energy is possible, but transfer of matter is not possible. Transfer of energy possible, but not the transfer of matter. Matter का transfer नहीं होगा. So in open system, we generally say that we don't have any type of boundary. वहाँ पे मतलब boundary होती है, but that boundary is of no use. ऐसा कुछ खास boundary नहीं है. But in closed system, you can see that transfer of energy is possible. So in this case, you will be having a diathermic wall. Diathermic wall, ये diathermic boundary है. So, for example, what are the examples? You have closed container, है ना, आपने क्या किया, आपने कंटेनर लिया, उसको बंद कर लिया, ठीक है। देन फॉर एग्जाम्पल व्हाट इज ट्यूबलाइट कह सकते हैं आप, बंद रहता है। एनीथिंग विच इज क्लोज ना, जिसमें आप यू कैन नॉट ऐड एनीथिंग एल्स, दैट विल बी नोन एज अ क्लोज सिस्टम। हेलो, अस्सलाम वालेकुम शिजा। शिजा, एम आई ऑडिबल?
अस्सलाम वालेकुम सर। यस सर।
वालेकुम सलाम। शिजा, आप कैसे नोट्स बनाइएगा? आप जैसे फॉर एग्जांपल यू हैव स्टार्टेड सम बेसिक कांसेप्ट्स इन दैट बैचलर, और यहाँ पे थर्मोडायनेमिक्स, तो हाउ आर यू गोइंग टू, कैन यू मेक अ सेपरेट कॉपी फॉर थर्मोडायनेमिक्स
यस सर।
एंड फॉर दिस, है ना, इस बैच के लिए अलग कॉपी बना लीजिएगा, ठीक है। तो
यस
यू हैव
सर।
टू लीव अ फ्यू पेजेस। हाउ मेनी पेजेस, शाइमा, टेल मी शाइमा, हाउ मेनी पेजेस इज डन शाइमा टिल नाउ? 2 pages, यानी वन शीट, राइट शाइमा? 2 pages means one sheet. Yes. Okay, so you can leave one sheet and then you can write from types of system.
यस सर।
So in this closed system, what will happen? We can transfer, energy, but not matter. Matter का transfer नहीं है. Write this down. Then we are going to see the last type of system. These are important, by the way. You have to know these definitions. Remember these definitions. Memorize these definitions and also know the properties. The open system, when we are talking about, then there will be transfer of matter and energy. Both the closed system will have transfer of only energy, but not matter. The type of wall will be diathermic, at least in both the cases, because in the open system you are also having transfer of energy. ठीक है, लेकिन वहां पे बाउंड्री ही नहीं रहेगी कुछ खास, है ना, दैट्स व्हाई यू कैन ऐड एनीथिंग. इन दिस केस यू हैव particular a real boundary, which is a diathermic wall, which allows the transfer of energy. Waiting for Aline, Alina, Ali, Jasleen, and Shaima. Shaima का तो हो गया चाहिए. शिजा, just wait. शिजा कहाँ गई? शिजा का हो गया. ओ, अली मोहम्मद अभी आए. अस्सलाम वालेकुम अली, am I audible?
वालेकुम अस्सलाम। यस सर।
क्या भाई, आप कब आ रहे हैं? स्कूल से कितने बजे आते हैं आप?
सर ये टाइम पे आता हूँ स्कूल से।
राइट नाउ? हाँ,
सर आज आधा घंटा लेट हुआ था सर।
आज आधा घंटा लेट हो गया. चलिए, लीव वन शीट, यानी 2 pages. आप जस्ट अभी आए ना?
यस सर।
ठीक है, उसके बाद आप यहाँ से लिखना चालू कीजिएगा. राइट द थर्ड टाइप ऑफ सिस्टम, दैट इज आइसोलेटेड सिस्टम. So in isolated system, neither energy nor matter can be transferred. Okay? So in this case, we'll be having a adiabatic wall. Wall और boundary एक ही चीज है. We cannot have a perfect adiabatic wall. तो आपके पास फॉर एग्जाम्पल थर्मस है ना, थर्मोफ्लास्क जिसको आप कहते हैं, थर्मस या थर्मोफ्लास्क, थर्मोफ्लास्क है ना, और या फिर यू कैन हैव टी इन थर्मोफ्लास्क. And one very perfect example of isolated system is the universe. यूनिवर्स में जो है वही रहेगा. Raise your hand if you're done writing. Everyone is done. Now, chase में भी diagram इसको बना के लीजिए. Since we are making this in all the cases, इसमें ट्रांसफर जो होगा ना ही मैटर का होगा और ना ही एनर्जी का ट्रांसफर होगा. ठीक है. इंस्टेड ऑफ मैटर समटाइम्स इन एमसीक्यू ना यू कैन आल्सो सी मास. ट्रांसफर ऑफ मास भी आप देख सकते हैं. राइट. तो घबराइएगा मत, एक ही चीज है. नाउ द नेक्स्ट टॉपिक दैट इज इंपॉर्टेंट इज स्टेट वेरिएबल. ठीक है. स्टेट वेरिएबल क्या है सुनिएगा जरा. द प्रॉपर्टी इज दैट द प्रॉपर्टी that define state of a system are called state variables. Are called state variables. ठीक है. हम बहुत अच्छे से आप लोग को समझाएंगे कि क्या स्टेट वेरिएबल होता है. जनरली तो प्रेशर, वॉल्यूम, टेम्परेचर एंड नंबर ऑफ मोल्स आर टेकन अ स्टेट वेरिएबल. इसमें से चार में से कोई एक को लिया जाता है जनरली. आई विल एक्सप्लेन. यू प्लीज राइट दिस डाउन. रेज योर हैंड इफ यू डन विद दिस वन लाइन. फिर हम आराम से समझाते हैं आपको. Like what is going to be state variable, and state variable is going to depend on what type of analysis we are doing, है ना. वेटिंग फॉर अलीना, अली, जस्टीन, शायमा एंड शिजा. जल्दी लिखिए एक पॉइंट को, फिर हम लोग बताते हैं. नो नीड टू ड्रॉ दिस, है ना. लेट्स सपोज यहां हुआ कप ऑफ टी. आपके पास क्या है, यहाँ हुआ कप ऑफ टी. नो नीड टू ड्रॉ दिस, समझिए बस, आराम से समझिए. यहाँ हुआ कप ऑफ टी. तो द कप ऑफ टी इट विल बी व्हाट. लेट्स सपोज इट इज अप्रोक्सीमेटली 60 डिग्री. यू ड्रिंक कॉफी. कॉफी है कप, मतलब कॉफी है, टी है, वट एवर यू वांट टू थिंक, है ना. इट्स समथिंग हॉट एंड इट इज 250 ml. नाउ दो सिचुएशन ले रहे हैं हम. This is what is going to define the T, right? It's this much hot and it is this much in quantity. इतना समझ में आ रहा है आपको? आया ना, पहले बताएं. Your T will be defined by these two parameters only ना, या फिर कुछ और पैरामीटर भी होगा? बताइए जरा. Think, you can think about it. You can think. The color of the tea will also matter, right? Like for example, if you drink a bit kadak tea, then it will be a bit more brown. But if you add more, let's suppose, if you add more milk, then it will be lighter in color. Makes sense? सुनो, अरे हाँ या ना तो बोलो भाई.
Yes, sir. हाँ, sir.
बाकी कहाँ है? अलीना, अलीज, आवाज ही नहीं पहुंचती है यार आप लोग की तो. Tell me. Think and tell me, is there anything that we can add in the, like that we can define the tea with? If you are asked to describe tea, the most important thing is that it is hot and it is 250 ml. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
Yes.
Yes, sir.
है ना? Hopefully the cup is not going to matter कि cup कौन सा है. बात समझ में आ रही है?
Yes, sir.
Right?
Yes,
Yes, sir.
चलिए ठीक है. Now there are two situations. There are two situations. पहले सिचुएशन में what happens, let's suppose आपके रूम में you have a cup of tea, cup of coffee. उस रूम में आपकी बहन भी पढ़ रही है, छोटा भाई पढ़ रहा है, सब भी पढ़ रहा है ना, उसमें आप भी पढ़ रहे हैं. और आप थोड़ी देर के लिए रूम से बाहर गए और आप जब रूम के अंदर आए तो आपने देखा, now the quantity that you have of tea, it is 400 ml. That cup, it has 400 ml and the temperature is room temperature 25 degrees Celsius. ठीक है?
Yes,
There is
sir.
another situation. In another situation, the amount of tea has been reduced to 100 ml. The temperature is 50 degrees Celsius. Can you tell me what happened in the A case and what happened in the B case, looking at the last end point? Like क्या हुआ है आपके टी के साथ? What happened in the first case? Tell me. B case तो समझ में आ रहा है ना? B case में क्या हुआ बताइए?
It's hot.
What? Zainab?
In B case, the tea is hot.
जोर से बोलिए ना, I cannot hear you at all.
In B case, the tea is hot.
The tea is hot. No, I'm saying what change happened? It was 250, now it is 100 ml. क्या हुआ बीच में?
It's less. The amount of tea is less.
Why? But तो क्या हुआ? आपकी बहन पी गई ना?
Yes, sir.
Yeah, ना, what you can conclude? Whoever was in your room, मान लेते आपकी बहन थी तो वो पी गई. She drank it. She drank the tea. So what about the first case? अगर ये situation आया तो what would you think? क्या किया उसने?
So she added water or something.
Very
in it.
good. है ना? She added water. Make sense? Yes or no? अरे भाई साहब बाकी लोग बोलो. She added
Yes,
water.
sir.
ठीक है? She added water. Now in the first case, you can see that in the first case, only if you see, you don't even have to touch it. You can see the amount of water as 400 ml and you can understand कि भाई इसमें पानी मिला दिया. समझ में आ रही है?
Yes, sir.
So in the first case, only this will be your state variable because that is defining the system, है ना, in one state and the other state. I don't want to talk about the temperature because instantly आपको सीधे पता चल गया. Like once you saw 400 ml, you will know that it is what water has been added. In the second case, what is in the second case? भी अगर आप देखें, the second case temperature is not going to matter. 100 ml is going to matter. You saw that okay, fine, it has been reduced. So what's going to happen? It has been reduced. That means she drank it, and by the quantity of 100 ml, you can say that okay, fine. What did she do? She drank it. So even though 60 degree is the property, it is a property of what? T. Here 25 degrees Celsius and 50 degrees Celsius, it is something that is defining a system. But we are right now not choosing 25 degrees as the temperature as the state variable. Does it make sense? Yes or no? Even though it is changing. Okay. So is temperature a state variable? Yes, temperature is a state variable. But is it a state variable in this case? No, it is not. बात समझ में आ रही है?
Yes, sir.
Yes.
Yes, sir.
ठीक है. So it is case dependent. Is temperature a state variable? In general question, yes. But in a specific condition, you will choose your state variable. Whatever properties you want to study, you are going to choose them. अरे आ रहा है, yes
Yes,
or
sir.
no?
Yes, sir.
Yes, sir.
चलिए, ठीक है. If you want to copy this situation, you can copy it. Otherwise, we will move forward. Can I move forward?
Yes, sir. Done, sir.
जिन्होंने नहीं किया है वो बोले नो सर. जो कर लिए होगा उनका तो क्या ही है, हम तो आगे बढ़ जाएंगे.
One second.
हाँ ठीक है. दिस मेक दिस अ हैबिट. व्हेन टीचर आस्क कैन आई मूव ऑन, जिसका नहीं हुआ है वो बोले. जिसका हो गया वो तो बोलेगा ही, मेरा जल्दी करो आगे बढ़ो सर, वो पढ़ना है. और बट जिनका नहीं हुआ रहता है ना, those who are not done, they should speak up. Sir, wait. Copy this down. Raise your hand once you're done. Anyone still writing?
Sir, I'm writing.
Anyone? You're writing.
Done, sir.
Now, another thing that is known as state function. ठीक है, ध्यान दीजिएगा जरा. स्टेट वेरिएबल क्या है? इट इज अ प्रॉपर्टी. हमेशा ऐसे याद रखिएगा, ठीक है ना. स्टेट वेरिएबल, व्हाट इज स्टेट वेरिएबल? इट इज अ
Yes.
प्रॉपर्टी. Then what defines the system, the state of a system, that is known as state variable. Right? State function, it is also property. It is also a property which depends. The property the properties of a system that depends only on the state of a system, only on the initial and final state value. Initial and final state of the system. Initial and final state of the system, but not on the process, the path followed by system. प्रोसेस और या फिर उस पाथ से नहीं करता ना. फॉर एग्जाम्पल, आई थिंक इस चीज आप जानते हैं. फॉर एग्जाम्पल, एक फिजिक्स का एग्जाम्पल है डिस्प्लेसमेंट. एनर्जी, इट इज ऑल्सो लाइक फाइनल एनर्जी. और एग्जाम्पल आप मान लीजिए, आप यू हैव सर्टेन एनर्जी इन यू ना, एंड यू स्टार्ट रनिंग, so you will lose energy, right? So you can say that. And similarly, let's suppose you have some energy and you start skipping. ठीक है, तो no matter like how, like what you are doing, आप कितना थके हैं इनिशियल और फाइनल पे ही डिपेंड करेगा ना. इनिशियल इतना एनर्जी थी, उसके बाद इतना एनर्जी, ठीक है. नो मैटर व्हाट यू आर डूइंग, यू आर रनिंग और यू आर स्किपिंग, व्हाट यू आर लूजिंग एनर्जी. और फिर आप जो भी थके हैं, दैट इज गोइंग टू बी बिकॉज यू हैव डन सम वर्क, इररेस्पेक्टिव ऑफ व्हाट वर्क यू हैव डन. ठीक है. एनर्जी उसकी तरह से, लाइक फॉर एग्जांपल टेम्परेचर, ये डिपेंड नहीं करता है कि मतलब टेम्परेचर जो है किस वजह से इंक्रीज कर रहा है. यू आर डायरेक्टली हीटिंग इट और यू आर यूजिंग माइक्रोवेव सो दैट द वाटर मॉलिक्यूल इनसाइड अ पर्टिकुलर फूड moves, and by that movement you create energy. टेम्परेचर टेम्परेचर होता है ना. इससे मतलब ऐसा तो नहीं है ना कि अगर आप तवा में गर्म करेंगे तो ज्यादा गर्म लगेगा, माइक्रोवेव ओवन में करेंगे तो कम गर्म। Make sense? So it is not going to depend on the process or the path. It is only going to depend on the initial and the final phase. Okay. Now, whenever we have something which is state function, तो उसको change जो होता है state function में, it is denoted by delta. ठीक है? That's this is important. This is where we are going to use basically change in state function is represented by delta. अब जो भी change हो रहा होगा, basic state is what? Final state minus initial state. नहीं, फाइनल वैल्यू माइनस इनिशियल वैल्यू जो भी आपका चेंज है। Now, similarly, we have another which is just the opposite, which is path function. Path function. Now, अब ऐसा नहीं कि path function is not going to depend on the initial and the final state. It is going to depend on initial and final state as well as the process followed. ठीक है? So please write with me.
Yes.
Properties of a system that depends on initial and final state, initial and final state, as well as initial and final state, as well as the process या path followed by the system. इस एग्जांपल में क्या आ जाएगा बताइए जरा। एक तो फिजिक्स वाला एग्जांपल हो जाएगा डिस्टेंस, सिमिलरली ईट, वर्क, these all of these things are going to be path function. उसके बाद लिखिएगा once you're done with this macroscopic properties. Macroscopic properties. ठीक है? now देखिए, this is basically properties of these are not the properties of one atom, one element, है ना? This are the properties of bulk of a substance. ठीक है? For example, mass, volume, temperature, density, boiling point, melting point, etc. Now, macroscopic properties are generally divided into two categories: extensive and intensive properties. ठीक है? Extensive properties लिखिएगा, extensive properties. हाँ, bulk मतलब group हो गया ना. For example, if I talk about water and I am talking about water molecule, then water molecule will not have any boiling point because that is a single molecule. सही है? So कोई भी ये नहीं होगा.
Yes, sir.
But if I talk about water, like 1 liter water, then it's going to have a boiling point of 100 degrees. So extensive properties में लिखिए. Depends on. Extensive property will depends on the amount or mass of a substance. Mass of a substance. For example, आप ना बढ़ा के देखिएगा, है ना. जैसे आप talk about water, let's talk about water ना. You have 1 kg water, now you have 2 kg water. Does the mass change? Yes, mass is changing. So mass is extensive property. I have 1 kg water, now I have 2 kg water. Will the volume change? Tell me, guys. Will the volume change? I have 1 kg
Yes,
water,
sir.
and the volume will change. So volume is also extensive property. Volume. Achha, what about number of moles? I have 1 kg water, now I have 2 kg water. Will the number of moles of water change? Yes or no?
Yes, sir.
Yes, sir.
Right. So moles of water. Okay. So these are what? These are extensive property. Another is intensive property. This depends, not depends, does not depend on the amount of mass of a substance. For example, ये बहुत आसान example. आपके पास 1 kg पानी है, now you have 2 kg water. Will the boiling point of water change?
No,
Will the
sir.
boiling no no नहीं change होगा. ठीक है. Example boiling point. Will the melting point change? No. Will the density of water change? If I have 1 kg water, now I have 2 kg water. Will the density of water change?
No, sir.
Density is also what? Intensity. Will the refractive index of water change? बताइए.
No, sir.
Right? Refractive index. Okay, so these properties are what? We can also write like will the molar mass change? Molar mass of water is going to be the same molar mass of air. Okay, copy this down. Temperature is also intensive ना. Temperature भी तो change नहीं होगा.
Yes, sir.
सबका हो गया. Ali just waiting for you. ये काफी फेमस सवाल है that how to determine whether something is extensive or intensive. ठीक है, so there are few things that I will write that's going to help you in knowing whether it is extensive or intensive. ठीक है,
Yes, sir.
इसमें कीजिएगा tips to find intensive और extensive. बेसिकली इसमें दिक्कत जानते कब होती है, बिकॉज देयर आर सर्टेन टर्म्स दैट यू डोंट नो राइट नाउ, है ना, जिस बारे में आपने सुना ही नहीं है, तो वहां पे आपको डिफिकल्टी को समझ नहीं आएगा इसको, लाइक इफ आई हैव 1 kg नाउ आई हैव 2 kg, वेदर इट इज गोइंग टू इंक्रीज और डिक्रीज, है ना, यू विल नॉट बी एबल टू अंडरस्टैंड दैट. ठीक है, सो दैट्स व्हाई आई एम राइटिंग दीस टर्म्स. बट बेसिक फंडा क्या है, लाइक यू ऑलवेज इमेजिन लाइक दिस, है ना, फंडा देगी, like if I have 1 kg water, now I have 2 kg water. Is that property going to change? First thing is that all temperature related or temperature related to a substance, for example like boiling point, melting point, melting point, freezing point तो same हो जाएगा ना, these are what intensive. ठीक है, this is going to be intensive property. Second, all energies in thermodynamics, just give me a second guys, all energies in thermodynamics are extensive. एनर्जी की बात आ जाए क्या हो जाएगा, एक्सटेंसिव, है ना. जैसे फॉर एग्जांपल ये गोइंग टू लर्न अबाउट, है ना, फॉर एग्जांपल एंथैल्पी आपने देखा है in the what chapter, in the third chapter, periodic properties, है ना, ionization enthalpy, electron gain enthalpy, all of those enthalpy we have seen. Enthalpy, then internal energy is shown by U, then you have Gibbs free energy. ठीक है, all of these things. And similarly एक energy का term है that is entropy, it's not really energy but it, जब पढ़ेंगे तो S से डिनोट करते हैं ना. all of these are what extensive. Third, all types of concentration terms, molarity, normality, pH, सब कुछ क्या होगा, concentration terms are intensive. If I have 5 liters of 2 molar solution, or if I have 1 liter of 2 molar solution, it is always going to be 2 molar, है ना. So these are what intensive. For example, molarity, normality, that is denoted by capital N, pH, then we have percentage, W upon W, mass percentage, volume percentage, all of these things. Fourth, all optical properties are intensive, है ना. For example, refractive index हम लोगों ने बता ही दिया. Fifth, properties which have molar, yeah, specific. If you have molar mass, है ना, specific density, specific conductivity, specific heat, specific resistance, all of these terms, molar या specific, are intensive. Molar mass, specific heat, specific conductance या resistance. ठीक है, six. Next लिखिए ना. Six, all constants of K family के फैमिली क्या है आपको पता चलेगा वंस यू लर्न इक्विलिब्रियम, लेकिन आपके एग्जाम में आ सकता है ना, लाइक वेदर इट इज एक्सटेंसिव और इंटेंसिव। तो के सी, के पी, के ए, बाय द वे ऑल ऑफ दीज आर कैपिटल के, है ना, हमने अच्छे से नहीं लिखा लेकिन आप तो समझ जाइए, ऑल ऑफ दीज आर अपर केस के ए। डिसोसिएशन कांस्टेंट बोलते हैं मेनली के को, डिसोसिएशन कांस्टेंट ऑफ एसिड का ए हो गया, है ना। डिसोसिएशन कांस्टेंट ऑफ बेस के लिए बी हो जाएगा। देन यू हैव के डब्ल्यू, दैट इज डिसोसिएशन कांस्टेंट ऑफ वाटर। देन यू हैव के एच, डिसोसिएशन कांस्टेंट ऑफ हाइड्रोलिसिस, आर। इंटेंसिव। सेवेंथ लिख लीजिएगा, रेशियो ऑफ टू एक्सटेंसिव प्रॉपर्टीज आर इज इंटेंसिव। टू एक्सटेंसिव प्रॉपर्टीज is intensive. For example, mass is extensive, volume is also extensive, but density it is intensive. Now mass क्या है? Extensive, volume is also extensive, density it is intensive. ठीक है, तो उस हिसाब से यहाँ पे आपको एक और चीज पता लगेगी प्रेशर के बारे में। ध्यान सुनिएगा, we have pressure। ये शिजा आपको नहीं पता होगा बट इसको ना अभी याद लीजिए, मे बी यू कैन लर्न इट लेटर ऑन स्लोली। पीवी इज इक्वल टू एनआरटी। अच्छा, पीवी इज इक्वल टू एनआरटी देखा होगा शायद आपने ना, शिजा आपने देखा है पीवी इज इक्वल टू एनआरटी पहले?
नो सर।
अच्छा, नहीं देखा आपने। प्रेशर इनटू वॉल्यूम इज इक्वल टू नंबर ऑफ मोल्स इनटू आर, दैट इज गैस कांस्टेंट, इनटू टी, दैट इज टेंपरेचर। ठीक है,
यस सर।
एनीवन स्टिल राइटिंग? नहीं लिखे तो ध्यान से देख लीजिए जरा। सो प्रेशर विल बी इक्वल टू एन आर टी अपॉन वी। ठीक है, तो यू कैन सी दैट टेम्परेचर तो नहीं है बट नंबर ऑफ मोल्स एंड वॉल्यूम, दीज आर व्हाट एक्सटेंसिव प्रॉपर्टीज, तो द रेशियो ऑफ दैट विल बी इंटेंसिव, है ना। या फिर और आप देख सकते हैं प्रेशर इट इज इक्वल टू फोर्स अपॉन एरिया। तो इफ यू इंक्रीज द मास ऑफ समथिंग, उसका एरिया तो बढ़ेगा। फोर्स भी क्या होता है? फोर्स इज मास इनटू एक्सेलरेशन। If you increase the mass, force is also going to increase. That means force is also what? Force is also a extensive property. Force is also an extensive property. Area तो extensive है ही। क्या हो जाता है? Force is extensive. Area is also extensive. So pressure is going to be intensive. Raise your hand if you're done. One kg water and 2 kg water, which has more area? Zainab. 1 kg, 2 kg, na? So it is going to be extensive, right? If it depends on the mass, तो extensive हो जाएगा।
Yes.
Waiting for Abir and Shiza.
Done, sir.
Done, done. हम यहाँ पे आपको सवाल लिख के दे रहे हैं, but it's going to be a homework, fine? Identify intensive and extensive properties. Temperature, modes, mass, volume, pressure, force, energy, molar enthalpy, density, specific conductance, specific resistance, molar conductance, तेरा specific heat, boiling point, freezing point, equilibrium constant, rate constant, length, area, इसको छोड़ दीजिएगा जरा, इलेक्ट्रोड पोटेंशियल, TH, 22 entropy. Entropy को ऐसे define कर. Tell me what happened?
So what is the 15th one?
Freezing point. होमवर्क है, ये अभी नहीं करना है ना, होमवर्क है। चलिए, इसके बाद देखिएगा थर्मोडायनेमिक प्रोसेस। बस आई ई कर दीजिएगा ना। फॉर एग्जाम्पल, टेम्परेचर इज, फॉर एग्जाम्पल टेम्परेचर इज इंटेंसिव। इंटेंसिव मोल्स विल बी एक्सटेंसिव, है ना, इस तरह से लिख लीजिए। राइट, नेक्स्ट थर्मोडायनेमिक प्रोसेस। पागल हो गए। अच्छा, thermodynamic process. Do you write process? Process which results in change of at least one state variable. किसी भी स्टेट वेरिएबल में से किसी एक स्टेट वेरिएबल में भी if there is any change, that then we call it is a thermodynamic process. Fine. Now, process can be done under certain conditions. So, for example, if you do a process in constant temperature, we will call it isothermal process. है ना? इसी तरह से हमारे पास कुछ प्रोसेस है, फॉर एग्जांपल आइसोथर्मल प्रोसेस। Isothermal process, in this case, what's going to happen? The temperature remains constant. Temperature remains constant. We have adiabatic process. In this, no exchange of heat. We don't exchange any heat here. Q is equal to 0. The third process is isobaric process. In this, pressure is constant. D में लिखिएगा isoporic process. Isoporic process. In this, the volume remains constant. Volume is constant during the process. E लिखिएगा cyclic process. साइक्लिक प्रोसेस में आफ्टर वेरियस प्रोसेस द सिस्टम इट विल रिटर्न टू इट्स इनिशियल स्टेट, बहुत सारा प्रोसेस होगा वापस नहीं आ जाएगा, ठीक है। वी कैन से दैट इट रिटर्न्स टू system returns to its initial state after various process। अब इसके बाद दो और हम लोग को पढ़ना है, रिवर्सिबल